Onion routing, OR, is a technique for anonymous communication over a computer network. Messages are repeatedly encrypted. And then, sent through several network nodes, called onion routers. Tor is free software for enabling online anonymity. It is designed to make it possible for users to surf the internet anonymously. It was originally designed, implemented, and deployed as a third-generation onion routing project of the U.S. Naval Research Lab. Individuals use Tor to keep websites from tracking them and their family members, or to connect to news sites, instant messaging services, or when these are blocked by their local internet providers. Journalists use Tor to communicate more safely with whistleblowers and dissidents. NGOs use Tor to allow their workers to connect to their home website while they're in a foreign country, without notifying everybody nearby that they're working with that organization. Using Tor protects you against a common form of internet surveillance, known as traffic analysis. Traffic analysis can be used to infer who is talking to whom over a public network.
In order for the components to communicate and exchange data, they will use cells. There are two types of cells: control cell and relay cell. A relay cell is not interpreted by the receiving node, but relayed to another node. The originator picks nodes from a list provided by a special node called the directory node. The chosen nodes are ordered to provide a path through which the message may be transmitted. This ordering of the nodes is called a chain or a circuit. No node within the circuit can infer where in the chain it is located, except for the exit node. No node can tell whether the node before it is the originator, or how many nodes are in the circuit. To make the concept easier, let's give a name for each node. Obtained from the directory node, the originator at this step has the public key of each node. Using asymmetric key cryptography, the originator uses the public key of the first node in the circuit to send an encrypted message, called create cell. Inside the create cell, the originator's half of a Diffie-Hellman handshake to establish a shared secret key, or session key, with entry node. The entry node replies to the originator in unencrypted plaintext, the entry node's half of the Diffie-Hellman handshake, and a hash of the shared secret. Now, the entry node and originator use their shared secret for encrypting all their correspondence in symmetric encryption. The shared secret is referred to as a session key. Using the established encrypted link to the entry node, the originator can then relay messages to the relay node through the entry node, using encryption that only the relay node can decrypt. To extend the circuit further, the originator sends a relay extend cell to the entry node, specifying the address of the next node, with the originator's half of a Diffie-Hellman key, encrypted with the public key of relay node. The entry node copies the half key into a create cell, and passes it to the relay node to extend the circuit. The entry node chooses a new circuit ID, not currently used on the connection between the entry and the relay node. The originator never needs to know this ID. When the relay node responds with a created cell, the entry node wraps the payload into a relay extended cell and passes it back to the originator. Now, the circuit is extended to the relay node. Both the originator and the relay node share a secret key. To extend the circuit to a third node, or beyond, the originator proceeds as before, always telling the last node in the circuit to extend one hop further.
The originator opens the stream by sending a relay begin cell to the exit node, using a new random circuit ID. Once the exit node connects to the remote host, it responds with the relay connected cell